So in the last part of the series, I'm just going to go over how to create a simple gradient effect, so switching from one color to another, and then adding a bit of noise in the middle there, so it has that nice looking transition. And then we can look at adding some twisting to the UVs as well. And what that'll take is first correcting the UVs, as each shape has their own UVs. We want to make it one continuous UV. Next, we'll look at coding that in Unreal Engine and what that looks like. And then we can start looking at the equation used to change from one material to another. So having a 0 all along here to a 1 all along here so that it can lerp properly, and then adding that noise in the middle and what that looks like in Desmos. And then lastly, we'll create that material in Unreal Engine and try a few tips and tricks to try and get this gradient looking a lot smoother and twisted as well. So without further ado, let's jump into it. All right, so from last video, arrows here already have UV coordinates set up when you make that sweep already, and it's already pretty good. The only problem here is because we've created two cylinders and we have no relationship between the two, they're actually just going to get their own UV coordinates from 0 to 1 on this left one and from 0 to 1 on this right one. But as you see, as I move this slider, what I'm doing in this one here is I'm having a UV go from 0 to 1, so I can have full control from the start to end. But if I have the UVs just like this, I have black here, and no way to differentiate a color here versus the color here because they're the same color. So what we want to do is get that 0 to 1 gradient, have black here, white here, and then a smooth gradient through here. And if I hop into Blender here, I can show you what's happening behind the scenes and then how we can rectify it. So if this is my unit of measurement, just one high at the moment, we can see that this cylinder or this arrow tail is too tall, and then we have this arrow head is one tall. So what we can do is we can say that this cylinder here is 2 out of 3. So if I go draw 2 out of 3 of the whole arrow, and then this is 1/3 of the whole arrow. And then if we have a look at the UVs as they come out of Unreal, we'll see that we're going from 0 to 1 for the top, and for that arrowhead as well, we're going from 0 to 1 as well. So what we want to do is we want to have this be 1/3 of the UV space. We don't want this taking up the whole UV space, and we definitely want this overlap between the two like this. So what we want to do is we're actually just going to a third this. So we're going to times this by a third. So actually, I'll do the cylinder first. So when we scale these UVs, we want to scale them from different locations. So we want to scale this cylinder up towards this way, but we want to scale this arrow down towards this way, so it makes up this bottom third. So we want the cylinder in that top 2/3. So we need to have different pivot points or different scale points for each one. So for this one here, we will scale this by 0.66 in just the one dimension like that, and we want to scale this 1/3, but we don't want to scale it like this because there's still going to be overlapping UVs if we do it that way. We want to do scale it the other way, so I'm going to change my pivot point to the bottom here. So if I cursor to selected and I'm scaling down the pivot point like this way, 0.33, and then we'll see that we get that smooth continuous. I didn't scale this one properly on just the one axis, but you can see that now there's no overlap, and now we get that smooth gradient from the end of the arrowhead, at the end of the arrow tail to the arrowhead, which is exactly what we want, because then we can have a smooth gradient in color in our code that goes from one color to another. So that's the aim. I'm just going to hop into the next part now. All right, so let's fix up these UVs. What we want to do is change it from this, something like this, where it's going from black to white and has that smooth gradient from one to the next. So if I go to my code, the first thing I did after I've assigned all my variables at the start, I've added this head to tail ratio. So if we go back into Blender, we need to have this either one of these values is fine. We can have this 2/3, or we can have this 1/3, and then we can deduce the other one from by if we have 1/3, then we can go 1 minus 1/3, and that's going to give us the 2/3, and we can then vice versa. So what I chose for is I'm going to do this 1/3. So the way I did that is I've parameterized the arrow tail length and the arrow head length, and 1/3 here's the 1, and this value coming out of here is the 3, which is just both lengths of these put together. So if this was 2, this is 1, it's going to get me 3 here, and so this is going to be 1/3, and that's my head to tail ratio. So I've changed the code a lot since last time, but the concept's still the same. Just before I do our sweep polygon, I'm just going to scale mesh UVs first, just before this, and we'll plug this up like so. So we have a scale and a scale origin. If you remember from the last section, is we want to scale from different pivot points. We want to scale this cylinder by this point, and this one here by a bottom point. So we will make this 0 for this one, and the scale is going to be this section of code at the moment is our arrow tail, and right now our head to tail ratio is has our head in mind, not the tail. So we need to 1 minus this, so subtract, and we need to get our 2/3. So we go 1 minus 1/3. That's going to give us our 2/3. Then we need a vector 2D as our scale. It takes a vector 2D as our scale, and actually it's going to be our y. That's going to be our coordinate that we want to change. We don't want to leave this x unchanged. We want just to scale it by 1, keeping it the same. Then I've got to make sure to bring this in like so, and chuck that up there. Just make sure it's all continuous. And scale origin. Let me just check. Yeah, that's 0, 0. That's fine. We will move this all across. And we'll do the same up here as well. So we'll scale our mesh UVs, but this time we're scaling just by that ratio. We don't need to have this one subtract. We can use this and make that vector 2D. 2D, and plug that into the Y. Don't want to change the X. Chuck that into scale, and here we're going to change our scale origin to be 1 and 1 instead, so it's the bottom that we're scaling. Chuck that in here, dine mesh down here, and that's about it. So if we compare this, also the other thing you'll find, actually, before I get to that, is that each of these arrows have different UVs on them. So this one's darker at both ends than these ones here, which is the gradient's kind of smoothing out without going into white at all on these ones. And we want a continuous UV set for all of these. And why that's happening is because we are scaling UVs. We're going to a for loop, we're making our arrows, we're scaling the UVs, but we're not resetting the UVs back to its normal scale. So it's scaling by a smaller value, going to the next arrow, scaling by a smaller value, and the UVs are just shrinking and shrinking as we go along because we're not resetting them. So the way I found to remedy that is by undoing this operation, and the way we undo that is by taking this value and scaling it by 1 divided by this value, which is the inverse, and make it vector 2D, put that into the Y, and chuck this up into our scale. Target mesh is that, origin is the same as well. Make sure that's right, and we'll do the same here as well. And our scale is going to be 1 divided by this, and making that a 2D with the Y as that. It's our scale. Make sure the scale origin is the same as this one. You can make that a variable if you want as well, but it should be good for now. If I compile that, let's have a look. All right, so let's look at the opposite way around here. Let me check I have everything right. All right, and yeah, what I found before is I need to switch these around actually. So I need to, for some reason I don't understand, is I need to actually switch these two around, and that seemed to work. I'm not entirely sure why, but there we go. So now we have that smooth gradient from 0 to 1, and now we can start making our material and changing this 0 to 1 gradient to a color to color gradient with some noise in between. So, all right, so now we have our UVs corrected. We want to do is change it around a bit. So instead of being a gradient from 0 to 1 here, we actually want it to be the same number here, so we get this blue color, and then we want it the same number here, 1, to get that pinkish color. So we want a function that goes from it's 0 for a while, and then it ramps up from 0 to 1, and then it's 1 for the rest of the UV space. So if I just hop into Desmos here, so first we need a kind of a scale of like how big we want this transition to be over. So right now it's about half of the material is affected by this transition, but I want some way of changing that as well if we need to. So I've just made this a number here. We can call that whatever. And this is our current UV state. So from the start of the arrow, our UV is 0, and from the end of our arrow, our UV is 1. That's how it normally is. And then what I want to do is, because we'll be adding noise to this, and I'll need some clamping as well. So I need to clamp it to 0, come up, and then clamp it to 1. So I actually need a linear equation that goes below and then above 0 to 1, so that we can then clamp it to 0 and clamp it to 1, so that we have these flat areas as well. So the first part of this is getting a function that goes from negative a all the way to 1 plus a over here. And then to figure that out, we know that the distance here is just 1 plus a here, and then a here, so it's 1 plus 2a. So that's our gradient. That's our change over time, and it's just over a distance of 1, so we don't need to do any other division or anything like that. And then our y-intercept, which is just negative a, as we want this linear equation coming through negative 3 here. So if we show that, then we have this equation here. So we're going below and we're finishing above. Then we want to have some randomness as well. So I've just added g. G is just a random lot of numbers. It's so random you can't even see this Desmos, but hopefully it gives you an idea. I've just done some large number crunching just so every input gives a wildly different output, basically. But if we add that to f, I've actually times this by 2 and minus 1, even before that, sorry. So what it's doing is it's making a really large number, and then it's modding it modding it with 1, which just means it's grabbing the fractional component, so it's always between 0 and 1. Then we're timesing by 2, so it's always between 0 and 2, and then we're minusing by 1, so that it's always between negative 1 and 1, and then we're timing it by a small number, just so we dial it down a bit, so it's not too hectic. So if we then just plus our linear function plus this bit of randomness, we get this here. But like I said before, we want to clamp anything below 0 here to here, and everything above 1 here as well. And the way we can do that, this is basically a clamp function. I don't think Desmos has a clamp function itself, but this is the same thing, which just does this, which is this red function now. And that's about it. There's our function, so it's staying white at the start, which is 0. Sorry, black, which is 0. It's going up, and then it's becoming 1 at the end, or white at the end. So there you go. That's the idea, and then we'll just jump into the code and implement this in our code. All right, so with our UV coordinates ready to go, we're just going to jump into making that new material. So I've just assigned this material here, m.tutorial, and I'll just expand this. So right now it's just grabbing that G, which is the V out of the UV coordinates, and using that for the base color. So that's why it's going from 0 on one end to 1 at the other end. Just using that V coordinate. What we're going to do first is set up some inputs. So we want a const vector3, which will be our color. So we can create a parameter and just call this color1. And I'll just do the same and call this color2. So let's make this random colors. That's good. And we want to be interpolating between these two somehow. So this is always going to be there. And then if we go here, so we have UV coordinates, base of 0.5. So if we have this being 0 to 1, if we have this as our lerp function, it's actually going to go from pink to end up going to this blue color rather than going from a black to a white. So if we apply that, you see that we're going from that pink color to that blue color, which is good. So if we jump back in here, our other input as well is our scale, like we talked about before. So if we go const, there's a pronoun we call this scale. This is 0.2 for now. And then we also want some noise texture sample. I'll need that as well, but this texture object actually. So that's going to be our texture, our UV coordinates. These are our UV coordinates here, so we can plug those in, and we'll just use that for now, but we can change that up as well. And bring our scale somewhere out of the way. And what we want to do is get the component that we only need one number from this noise value, so I'll just get the R value, and I want to remap this. So right now, the values out of here are going to be 0 to 1, but we actually want to make it negative of this scale to positive of this scale. So then we can add what that noise is, which can only be from -2 to +2. So we're only adding that little bit of noise if it's a little bit of scale, but if it's 0.6, then we can have an influence of 0.6 in total, or 1.2, which is -6, 0.6 to 0.6. So I will put this to the target high and then multiply this by 1 to get our negative -0.2, and that's going to be our low. So we have a value that goes from 0 to 1 to then -0.2 to 0.2. Then we want to, let's see, I found out that this is actually the wrong way around, and we actually need to do 1 minus this. Switch that around, and I'm going to have another input here, actually, which is going to be time, basically, which won't actually be a constant. We'll change that later, but I want to add this. So this time value that we're going to create later on, we're going to keep adding to this this alpha value that we're going to put into here. So eventually, when time becomes a really big number, this alpha is going to become a really big number, which is going to mean that this blue is always used and this pink isn't used. So that's how we transition between a total pink color to a total blue color, by using this value to get really high. And what I want to do is make it that if this value is 1, then that means that this alpha is always at least 1, so that this can always be blue. And yeah, have 0 be fully pink as well. That's the idea. So add these two values up. So we're adding this 0 to 1 value, or 1 to 0 value, and then adding a bit of noise to it, and this noise is going to be only a little bit, so like negative 0.2 to 0.2 as I said before, which is good. And then before we chuck this into the lerp function, I actually want to clamp down this just to make sure that it's between 0 and 1. If it's above 1, it might go past blue to outside of this range, which is never what we want. So check that in here, and we can have a look at that. That should give us something. There we go. So that's looking all right for now. And then if I change this time value to 0.4, then we should see it get a little more blue. So there we go, it's come up further. So then we can animate that at a later point. And I don't think you can animate with just a constant value, so we're going to create a collection parameter. It's called a material collection parameter to control this, and then we can chuck in a sequencer, and then we can animate it. That's about it. The one thing, actually that's not too important, but if you want to change this from being linear, you can change it to be exponential. If because I noticed I was getting, you can kind of see that blue drop off here, and you can sometimes see this pink drop off here. So you can play around with different functions as well. So if I, for example, I can multiply the output from here by itself and make that the alpha instead. And if I jump into Desmos and I will just hide these. So if I go x squared, which is what I'm doing basically, and then have this go from 0 to x to 1, you'll see that instead of going from 0 to 1 linearly, it's just being more closer to 0 here. And then also you'd probably want it to be closer to 0 here, so it's kind of like an S curve. But you can play around with that and use your own function at your own discretion. I won't be doing that in here though. I'll keep it pretty simple, and that's about it. You'll see though that the interpolation between colors isn't that great. So if I had a good example of this is if I have a color that's completely red and going to a color that's completely blue and apply that, you see that as it's interpolating in between these two colors, you'll see that there's a lot of gray around. And if you're wondering why that is because halfway between red and blue is actually, it's just a gray color. So halfway between 100 and 001 is just 0.5, 0, and then 0.5, which is just a gray color, or a gray white, a gray black color. So it's a gray, black, gray, which is great. So there's ways you can get around this, and that is by converting to RGB to HSV. So do the same thing to the blue color as well, and then we can interpolate between these HSV values and use those instead. So if we lerp between these two, and then we're still stuck with a HSV value, which is why we're getting these weird colors here. So we need to convert back to RGB like this, and then we can plug that in. And you see that's actually not right. That might be right actually. I just need to reduce this. And time, dial that back. Or is it the other way maybe? That's going to be crazy actually. I'm not too sure what's causing that, but as you can see there, it's getting from blue to red, but it's not going through any gray colors. It's going kind of around the color wheel rather than through the middle, through that gray area, which is what we want. which is good. And the other thing as well is that twisting that we can do just by using the other coordinates. So we have our v coordinate is just going around. So if we add to this coordinate that's going around, which is our u, if we add it by v, which is this number across here, we'll get that twisting. And I can show you that by just, so we'll mask this out to get our u value, which is our r value, and then we can add this, so add our g to our r, and then make that our r. So if we go g, we use our g, and then we append, and I always don't know what to append. I think it's this one. So we have a g, actually, g should be the second one, and our r here is not this r, but our added r. And then we can use this as our UVs instead. And as you can see, it looks a bit twisted already in here. It's a bit twisted here. Hit apply. Then we get that twisting color, which is really cool. And I'll just show the animation part as well. So right here, I've just created I wonder if we'll be able to find it. Miscellaneous, I think it is. Material. That's a material parameter collection, and I've just added one here, which is just one value, alert value, default 0, and then that just lets us put it in our sequencer. So if I've dragged alert value in here, I think you go track, and then you go down to material collection track, and then you click that here, and you can choose which value out of that data set you want to use. And I've just made some keyframes here, so it's -0.3 here, 1 here. But if I go into this material again, I can reference that by material collection, or the collection parameter unspecified, so I can choose which collection, the only collection, and then that alert value. And instead of using this 0.1, I can use this value instead, save that, and then you can see that we can go between one and the other. And if I wanted to show this going from completely blue to completely red, I can click here and just dial it down to red, and there we go, we got that animation. It's a bit high on the scale. Let me see if I can actually change that properly to, that seems to make it bigger. Not too sure what's causing that, but you can play around with it and get whatever result you want. I can even change the colors to be something a bit nicer than that. And there you go. No, or very little of the grey colors, and animates nicely. All right, so just one last thing I wanted to correct. So this scale value we had here, I've now called that intensity, and it wasn't exactly doing what I thought it was. So if I go back to Desmos here, what that scale value I had was doing was just changing the scale of the noise, and what I wanted it to do was to change the gradient of this linear equation so that it can go down and steeper and shallow if it needs to. So this should be doing this instead, but it's not. So the way I fixed that, I did end up keeping this variable called intensity, which I can show here. I've added as a material collection parameter, and when I change this, you'll see that it just increases the sharpness of this. If I turn it really high up, then it's always going to be orange or purple. It's not going to be any gradient in between. So I can turn that up and down if I want to as well, but usually you want to keep that pretty low like this. So then I've added this noise scale as that A value properly. So now you can see that if we dial this down, it goes over a longer duration. If we put it up, then that noise is only taking up a tiny bit, tiny bit of a transition between these two colors. And the way I did that was, so just before we didn't have these or this, so I've added this noise scale, and just like before in our equation, we want to times the gradient by some amount dependent on A, and then we want to subtract A from it as well. So I've basically just done that in a roundabout way. So I've multiplied it by A, and then add um, our mask minus by A as well, so that where if I didn't minus this and I would change the scale, the texture would go off screen as I scale this up. So now if I scale it up, it's kind of it's staying the same spot kind of, but if I didn't subtract, then it would go off screen, and I'd have to change these two values around. So that's a way of getting back into that same range. Hopefully that makes sense. But so that's about it for this tutorial. I'm just gonna leave it at 4 parts, but if you guys have anything else you'd like to see added, let me know in the comments. I can try and add that in a future video. But as is, I'm pretty happy with how this turned out, and I'm just gonna leave it here. If you have any other recommendations of any other projects I should get into around geometry scripting, let me know. I'm always up for ideas. I think ideas pretty hard to come by for me, so I'm not really a creative person. But if you have anything you'd like me to tackle, I can definitely look into it and see what I can pull off. But yeah, thanks for watching, guys, and I'll see you on the next one.